Everybody, welcome. So we're just coming up at 2 o'clock there in Dublin time. So welcome to everybody who's joining us today. So we have a very nice event planned here. We have about 60 participants or so it's going to be quite busy. We're going to ask all of the participants to keep their cameras off. We'll start in a second or two, but just a couple of little reminders before we get going. So our etiquette. If we just do our quick introduction. So welcome to the EURO Wisdom Forum set of lightning talks, where we're highlighting the excellent work of some of our young women for OR. And today's theme is energy and transport. So OR in the energy and transport sectors. We are recording this presentation, so just be aware of that, please. We're recording, and we hope we'll make the presentation available afterwards on the EURO website. As I said, we've about 60 or so people who are hoping to attend today. So we'll ask all of you to keep your cameras off unless you're a speaker, and to keep yourself on mute. The format for today is that our speakers will do their lightning talks, then we'll have some general discussion, and then we will go to some breakout rooms for coffee. We'll explain more as we go. So I think we're just gone past 2, so I think we'll get started because we have a lot to pack in today. Just a reminder of what the Wisdom Forum is. So it is a EURO forum, so that's a general interest group who share the same ambitions to support, empower and encourage the participation of all genders within OR, within EURO. So we have a couple of actions and ambitions that we're trying to progress, so we're delighted to have your support to achieve those things. So we've made some recommendations to the EURO executive, and we're delighted to report that they have endorsed our white paper, which is now available on the EURO website. We're promoting and championing young women in OR in particular, and that's one of today's events. And we're promoting this general conversation around how OR can be utilised to create a diverse and inclusive future. So lots of interesting things happening. Thanks, Nuncia. So just one of our initiatives in Wisdom is this Young Women for OR. So we're delighted that we have such a strong presence of women within OR. I think anecdotally, we're all saying that OR is a welcoming community. So we're delighted about that. This is our 2020 Young Women for OR. We had a lovely presentation by Mercedes last month, facilitated by Ivana on facility location. That's up on the EURO website. And in bold print there, you can see our speakers for today. The other speakers will have a webinar in September. Thanks, Nuncia. So today's presentation, as we said, OR in the energy and transport sector. These are our list of speakers. So thank you to all of them for sharing their time with us. They have developed a huge depth of expertise. So we only have 5 minutes to hear from each of them today. We'll have other opportunities in other Wisdom events later in the year. But thank you to them for their very short presentations, just briefly highlighting their work. And a huge thank you to David as well, who's our subject matter expert, who's going to give us some commentary as well and synthesize things for us after the short presentations. Okay, I think that's everything from me. Handing over to Martina.
Thank you very much. So yeah, my name is Martina Fischetti, and I'm today talking about operation research in wind energy. And I'm also the only one from the young women in OR that is today working in industry. So I'm also trying to give it a little bit of a cut on the industry perspective. So you can go to the next slide. I'll talk a little bit about myself. So I have a background in engineering from Padova University and Aalborg University. And then I did a PhD in operational research at DTU. Actually, David Pisinger was my supervisor. And this PhD was already an industrial PhD, so a very close collaboration with the company. And the company is Vattenfall. Vattenfall is a big energy company in North Europe that cover different kind of energy. And I always focused on renewable energy and wind energy in particular. In my PhD, I worked on mathematical models and algorithms for offshore wind farm design. So focusing on the design phase of wind farms, and so deciding where to locate turbines to maximize production and minimize position-related costs, as well as their electrical connection to minimize immediate and long-term costs. Today, I'm still working in the same company, Vattenfall, where I'm a lead engineer in operation research. My main task is to lead the optimization focus area in the group and to scout for new projects and new interesting challenges in optimization in the company. I'm also tech leading in some projects, in particular in an optimization project related with maintenance planning. So I work on different applications in wind energy. The one I will talk today is my industrial PhD one, that is the wind farm design one. And then I work also on maintenance planning and construction planning. Next. So regarding to the methodology I've used, I started by writing mathematical models. So here I'm focusing on my PhD, so the wind farm design problem. Something interesting of working in a company or with a company is also that you look at problems with a different angle. So actually, part of my PhD work was also to formalize for the first time some very practical problems from the company that required, talking with a lot of people with very different background, as these projects were very multidisciplinary. Another challenge in working in a company is also that you may end up realizing that what you need in practice is maybe more complicated than what you expected from a research perspective. Especially in my case, this regarded the large scale of the instances I was facing during my PhD. And for this, I use some materialistic approaches. Meta-heuristics are a mix between synergic use, let's say, between meta-heuristics and exact methods. So here I give you the references to the two main papers where I use these approaches in two different flavors, so two different techniques, but both meta-heuristics techniques. Something that I also enjoyed very much of working in a company is that the tools I developed have been used in practice, and have been actually some enablers for the company to put numbers on what they were doing, enabling them to do to challenge what they were doing, challenge their rule of thumb, and do a lot of what if analysis to decide exactly how to proceed in the design. So in this part also, when we're talking about the future where there are a lot of what if analysis to do, I use also some machine learning techniques together with classical operation research techniques, to tackle a large number of what if analysis. And also here you have a reference. Next slide. So to conclude, my PhD was actually very interesting, both from an application perspective and an academic perspective. So it always had these two souls. From an application perspective, it was used in practice, and in particular, I mentioned here Holland-Kust-Zuid. That is the site where these tools have been used and were instrumental for us to win the site, and so being able to construct it. And I'm particularly proud of this because Holland-Kust-Zuid is going to be the first site ever constructed subsidy-free. So this is a huge milestone, not only for Vattenfall, but also in general for the wind business. The company also had a lot of savings using these tools, so using operation research compared to the traditional methods they were using before. And it also created, as I mentioned, new momentum in the company, the creation of a new group, and a lot of questions that were finally answered in a quantitative way. From an academic perspective, it was also a good project because there was a formalization of new operational research problems. And also we approached different methods to solve complex cases. I was able to publish on different journals, and I was very honored also to be awarded with different awards. And the one I care the most probably is the EURO Doctoral Dissertation Award in 2019. And I'm also super proud that we went to present our work as a finalist of the Franz Edelman Award. We didn't win, but it was a great honor to be there. So there is the picture with also David Pisinger on the stage. So this concludes an overview of me, who I am, and what I've done in my PhD mainly. And then I can take further questions later, or I will present also the EURO session. Thank you.
Hi everyone, thank you. I am Meltem Peker Sarhan. Today I want to give you a bit overview of our current study for the assessing flexibility of residential demand response under uncertainty in distribution network. For the next slide. First, let me introduce myself. I received my MS and PhD degrees from Department of Industrial Engineering, Bilkent University, Turkey in 2013 and in 2019, respectively. And after finishing my PhD, I joined to Newcastle University School of Engineering, and currently I am working as a postdoctoral research associate with the school. My research interest mainly focuses on application of OR in energy and power system, power system operation or electricity market design, and also I am working on network design as well. In my both PhD and in my postdoctoral research, I have been working on projects related to designing flexible energy systems. And as you know, increasing renewable energy sources and also uncertainty increases complexity of power and energy systems, and using various mechanisms such as smart grid technologies, storages, electric vehicles, or demand-side management technologies, I am working on projects for the designing flexible energy systems. Next, please. And today I want to give an overview of our current study, which I use one of the various control mechanisms as demand-side response. And I will discuss more in EURO conference in July for this study. Let me first introduce demand-side response. Demand-side response is a term that is used for reduction or shift in power consumption to maintain supply and demand balance in distribution and also transmission networks. And since residential demand response constitutes 20% of total worldwide energy consumption, it has a nice it has a good supply for flexibility to the grids to change or to maintain the supply and demand balance. However, in this study, we discussed that customer behavior uncertainty highly influence load uncertainty, which also have a great influence on operational and planning decision of network participants, such as aggregators or network operators. And in this study, we aim to assess flexibility of residential demand response under uncertainty. And also, secondly, our aim to investigate the impact of uncertainty on service providers, as I said, aggregator or network operators' decision. And to fulfill this aim, we proposed a robust mixed integer convex model, and we propose a robust mixed integer convex model. And also to solve this model, we use a state-of-art algorithm, which is Kalman constraint generation method, to handle the computational complexity of our problem. We implemented a well-known data set from the literature. We use well-known data set, which has 500 and 900 households on a distribution network. Next slide, please. And by using our computational study, we learned that uncertainty plays an important role in service providers' decision-making. And we find out that when uncertainty is considered, electricity costs and peak load of the system increase significantly. And also location of households that the flexibility will be procured from change significantly as well. And secondly, by including uncertainty, we also observe that when a higher level of robustness is required by the aggregator or network operator, location importance is indeed magnified. And magnified, thank you. By using as a conclusion or as a deduction, we say that accounting number of location of households on the network may affect service provider strategies. For instance, aggregator may also consider location of households that the flexibility will be procured. And also, secondly, in this study, we propose a general framework to find a benchmark. And this kind of benchmark studies can be also used to investigate where synergies and conflicts appear in decision-making of different network participants, aggregator and network operator as well. And as I said, in this study, we only discuss our results using a centralized framework. However, we aim to continue this study by using decentralized approach because customers may have different objectives, as you know, minimize cost, or they may even consider carbon dioxide emission. And the second important thing from operational perspective, privacy and security issues are maybe the most important for real life applications of this study. So our next steps for this, thank you for giving a chance to give an overview, and I am happy to discuss later.
All right, it's my turn. My name is Alina Gabriel Dragomir. I work at the University of Vienna at the Department of Business Decision Analytics. For my background, I finished my PhD in 2020 at the same university under the supervisor Karl Dörner. And for my postdoc position, I'm focusing on city logistics in general. And the first topic in that is the large-scale waste collection problem. It's large scale in that case because it has over 270,000 nodes. So it's a very, very large scale problem. And the scope of this problem is to solve basically the waste collection problem in Vienna based on all the addresses that we have in Vienna. So the picture you see is a heat map of all the addresses that you can see. And if you're familiar with Vienna, you can very nicely see the river that flows through it and so on. And for this problem, it's a periodic problem. So we have multiple periods. We have multiple depots with different sizes, so between 10 and 75 vehicles. And the underlying routing problem is a capacitated vehicle routing problem. What also makes this a little bit more challenging is that we want to use real world distances to make it realistic. And the problem size itself makes it a very difficult problem for traditional approaches, because you cannot just use your standard traditional algorithms, because usually you run out of memory. So for example, a distance matrix for this problem has over 75 billion entries. And it's simply not possible to do what you usually do, just calculate out the distances, read them into memory, and then use them to use for your algorithm. Next slide. So what we're trying to do is, on the one hand, we're trying to use machine learning concepts to estimate the distances. So because we have so much data, we have 75 million entries, we can very well use this to get then a factor with which to multiply the Euclidean distances with. And the Euclidean distances are easily to compute because you can just calculate them. And use this as kind of as a measure to then use these estimated distances for our routing solution algorithms. And the difficulty is that you always have to balance the solution quality with the memory requirements and then the computation time, because not being able to save things means that you have to compute them over and over again. So this would increase computation time a lot. So as a start to solve this, we decided to split it up into a scheduling part for when each customer is going to be visited, and then into a routing part. And this routing part again split into a depot assignment and then the single depot routing. And the single depot routers, which is our for this depot assignment, we used like a round robin approaches. As a construction heuristic and as an improvement heuristic, ruin and recreate and local search. And yes, so the single depot routing still has up to 40,000 nodes. So it's the single depot, single period, capacitated VRP are still very large. As I mentioned, maybe it's still work in progress. These are basically the routes that our construction heuristic provides. They're far from optimal, but it's a start for this problem size. And what we are trying to achieve is that we have both an expansion in the large scale VRP field, because it's both a larger problem that has been solved before and also a more complex problem, because the largest VRP instances currently have, I think, 30,000 nodes. And also, of course, expand in the field of the multi-depot periodic vehicle routing problem. And thank you. And what's also might be interesting to incorporate this machine learning aspect, because we've seen from other presenters and from other very smart people in our field that at least for now, it seems like a really useful tool, but it's not that promising in terms of routing solutions. So using it maybe for a different aspect, but still which is an integral part of the of our problem, might make this a very interesting topic. Now, as I said, this is work in progress. So for the Euro, I will present a different topic, namely a finished one, which deals with concepts for package delivery, where we look at having alternative recipients and alternative locations for the package deliveries in the city logistics context. But this is still work in progress, so it's not going to be finished until the Euro, unfortunately. Thank you.
Good afternoon to everybody. I'm Annarita De Maio. Now I'm postdoc at the University of Calabria in the supply chain management and logistic field. And today I will introduce you a work that I developed during my PhD that is about the multi-depot inventory routing problem in a megacity environment. Next, please. Okay, this project is developed with the collaboration of the Procter & Gamble, and in particular the company want to understand and to investigate the convenience of apply the vendor managed inventory framework in the last mile delivery within a megacity context, so a city that is featured by the presence of millions of inhabitants. This sector is very important for the company because megacities are particularly present in the emerging markets, and the company has a high level of sales in these territories. So the interest of improve the last mile delivery is very high for the company. In particular, they propose a case study that is related to the Surabaya city, that present more than 6 million inhabitants, and the main scope is organize the deliveries for 947 nano stores with an homogeneous fleet of vehicle and in an horizon of 6 weeks, 6 days, consider it so 1 week. And considering also that the urban area is divided in 12 different zones for some managerial aspects related to the contract with different carriers. What we have to observe is that the company is interested also in considering the possibility to make a framework with only one depot or a framework with different depots inside the different zones. Finally, I have to precise that the problem is challenging because it is an inventory routing problem, but also because of the nature of the stores that are nano stores. Nano stores are supermarket, hypermarket, or sometimes also some kiosks that are very close each other inside the urban area and also are affected by small space for inventory, small availability of cash for making orders, so their demand is very small and they risk very often stock out. Next slide. For solving this challenging problem, we firstly develop a multi-depot IRP formulation that is based on flow variable, and we consider some hypotheses that are made up in agreement with the company. So no inventory constraint to the supplier are considered. The cost of inventories to the customer are negligible, and we allow also split delivery between from different depots to the customers. For solving the problem, we develop a heuristic algorithm divided in different phases and a branch and cut, a classical branch and cut with some classical inequalities for comparative purpose. The algorithm is based on the hypothesis of decompose the complexity of the problem. So we try to cluster the customers to the different depots, considering their critical level, so balancing the risk of stock out and the distance from the single depot. In this way, we are able to assign the customers to different depots and to making the construction of feasible routes inside the different clusters. At the end, we optimize the main problem with a route-based formulation in order to understand which is the best planning for deliveries, the quantity to deliver to different customers, and when. In particular, we observed that the blind division of the customers between depots is not so effective. So we have to introduce the possibility to serve some customers in the borderline of the clusters from different depots. And so we make an optimization, also consider inter-cluster route and not only intra-cluster route. This
1 minute.
Thank you. Necessary for the particular nature of the nanostores and the distribution inside the city. Next slide. We have we test some benchmark results. I don't give the detail. There are some detail in the table, but what is most important is the results related to the case study, because we are able to reorganize the area inside the 12 zones and to solve instances from 28 to 138 customers, while considering that the benchmark instances are only up to 50 customers. We compare the multi-depot framework and the single depot framework, and we are able to observe that in terms of total kilometer reduction, we obtained 22 of saving kilometers with the single depot framework, comparing with the actual situation inside the company, and the saving on the 33% for the multi-depot framework. More details are reported in the two references that I put on the slide. What is important is that the company find these results very interesting, and so they decided to try to develop a piloting project also with the ICT infrastructure for applying the VMI inside these emerging markets. And so now they are evaluating the investment of the piloting. This is a very good result from my side, because I think that operation research should be very useful in managerial context for companies, and so I'm very proud that the company really appreciates the results of this part of my PhD. So thank you to everybody.
Good afternoon to everybody. Thanks for this opportunity. I'm glad to participate in this initiative that helps us to know each other and gives visibility to our work. You can move to the next slide. My name is Lavinia Amorosi. I am assistant professor at the Department of Statistical Sciences of University of Rome Sapienza. My background consists of a bachelor in math, then a master in statistical and decision sciences, and then a PhD in operation research. Since my master thesis, I started working on combinatorial optimization, mainly on networks. And during my PhD, I focus also on multi-objective programming, in particular on two-phase methods for bijective integer network flow problems. Beyond the methodological issues, most of the problems I studied and dealt with derive from real-world applications in telecommunication, deliveries, and inspections using the unmanned aerial vehicle technology. And the problems, the optimization problems arising from the adoption of this technology are the topic of this short presentation of today. Indeed, when drones are involved in service systems, several issues must be considered. For example, in the hybrid systems where drones are supported by standard vehicles that are used mainly as recharging stations due to the limited endurance of the drones, we need to coordinate their operations. Or when the drones are adopted for providing 5G connectivity, for example, in rural areas where there is a lack of infrastructures, always because of their limited endurance, we need to plan their recharging schedules, while guaranteeing constant connectivity. You can move to the next one. From a methodological point of view, I faced these problems by means of a mathematical programming approach, formulating node or arc routing problems, which embed additional constraints due to the adoption of the drones. As I mentioned, recharging constraints must be included to deal with the limited endurance of the drones, and coordination constraints for hybrid systems where the drones operations are supported by a standard vehicle, like for example a truck or a boat, which works as a recharging station and mobile depot. The formulations proposed can be solved at optimality by commercial solvers like Cplex on small and medium-sized instances, but exploiting them, it has been possible also to design heuristics able to provide good quality solutions in reasonable time, also for large-size instances. Another important part of my work on this topic was devoted to the generation of instances on which the formulations and heuristics have been validated and tested. Indeed, we adopted real technological parameters like the time for recharging batteries, energy consumption, speed, and so on, and realistic scenarios also in terms of demand distribution over the territory under consideration. The next slide. These studies permitted us to answer to, let's say, two main questions and thus provided some important insights. First, we learned that it is very important to find a trade-off between the capability of the models to capture the characteristics of the real problem and their practical applicability in the real world. Indeed, it is important to formulate models that can be solved or even when they cannot be solved at optimality in reasonable time on real large-size instances, they provide a first feasible solution of good quality, or they permit to design fast algorithmic procedures based on them.
1 minute.
Thank you. Another important issue is related to the data that are used for feeding the models. Indeed, it is very important in order to obtain applicable models to well study them before making decisions in modeling. For example, studying the demand in delivery problems, the demand distribution, it is extremely important in order to understand what is the more appropriate system to adopt for dealing with the problem, and thus what formulation is the more appropriate. Obviously, the efficient planning of activities like deliveries, inspection, or internet coverage permits to reach several goals, having an impact in the daily life. The adoption of drone technology leads to more sustainable last mile deliveries, or permit to provide in a more systematic and safe way emergency services after post-disaster in post-disaster scenario, like after an earthquake which destroyed the standard traditional infrastructures. However, in the work I made up to now, I consider always deterministic models, but there is a wide area of research related to data analysis and extensions of this model to the stochastic case that I would like to investigate. Obviously, I would really enjoy if someone interested in these topics would like to collaborate. And I thank again the organizer of this initiative, and I hope it will be only the first one of long series to promote the work of young women researchers and new collaborations. Thank you.
Thank you very much to all of our speakers. They were fantastic. So I've taken some notes and I've loads of questions. But before we get to that, I'm going to hand over to David. So David is going to give us some synthesis, if at all possible, of all of those fantastic presentations. David, over to you.
Okay, thank you very much. Can you see me?
Yes, far ahead, yep.
Good. So first of all, thank you for having given me the opportunity to comment on these 5 very interesting presentations. And I'm really happy to see young women are leading in the green transition of our society and solving some of the challenges of the future. When I was young and working on knapsack problems, basically problems with one constraint, I can now see how big and complex problems you are solving. And I also can notice that you use many different techniques spanning from classical deterministic OR models over stochastic programming, decision science, and machine learning. And I find this very interesting. In machine learning, there's this tradition that if it works, it's good. In operations research, we more have this, we want to be somehow well-proven techniques, etc. And it will be interesting to see if OR develops in the same direction that, okay, if it works, then then let's just move on. Now, I've been asked to give an overview of current challenges and synergies with this existing work. And to quote a Nobel Prize winner, Niels Bohr, he once said, well, prediction is actually very difficult, especially if you have to do it about the future. So if you want to hear my 2 cents about the future of OR in energy and transportation, then definitely some of the drivers will be that we will see this green transition, you will see new modes of transportation, autonomous vehicles, electric cars, etc. And this will put up a lot of new constraints on our problems, but also new opportunities. Also, a driver will be the big data revolution. So we have lots of historic data, but we can also in real time get information about where vehicles, what is the power consumption, etc. So this will definitely define the problems of the future. Another interesting thing is that now every cell phone basically can run an optimization code. So just an example is Google Maps that can find the shortest distance to any place. But if everybody uses the same algorithm, then you will see a lot of congestion problems. So it will be interesting to see if we can make models that can make all these individual optimizations works together instead of actually harming each other. And finally, I think the combination somehow of operations research, artificial intelligence, and machine learning, what people sometimes call decision science together, will really be interesting to follow in the coming years. I prepared a few words to each of the speakers. So if we start with Martina, well, I know your work very well since I've been standing on the sideline, and you have already shown some excellent results and contributed very well to the green transition as illustrated by the many prizes. And you also showed that you can mix many different techniques, both exact methods, heuristics, machine learning, etc. And I think one of the next big challenges will be to see how to integrate these techniques for wind farm design into collaborating with the grid. So somehow considering power to X technologies to handle uncertainty and to find out what is the demand, energy prices in the future, etc. And in this respect, I think it could be interesting to collaborate with Meltem on the flexibility in power networks. But overall, very interesting work. Then Meltem, I found your talk extremely interesting about basically finding the flexibility in power consumption. Just as an example, in Denmark, 46% of our energy comes from wind power, but unfortunately a large amount of this energy is produced at night where we don't really need it. And actually Denmark could have produced some 10% more wind power, but the turbines were stopped because Germany did not want to take the energy because that would somehow spoil their price level. So somehow studying this flexibility in the power supply is extremely interesting. I've seen applications in cooling houses where you need to keep the temperature between some upper and lower limits, greenhouses where you need a specific hours of light, but you don't necessarily need to have them at specific hours, swimming pools that should be between some degrees. It would be interesting to see whether some of this flexibility could, for instance, be built into the wind farms that Martina was talking about earlier. But again, thank you for some really interesting work. Alina, I really enjoyed your work on large-scale routing problems, and I can see that much has happened since Stefan Röpke and I worked on vehicle routing problems, solving Solomon's instances with 200 customers. And you're also an example of using big data in solving these problems, and also what challenges it gives to deal with large-scale problems. And I really like your approach to use machine learning to predict distances. And perhaps it could be even more interesting to predict travel times or energy consumption of the vehicles. This is information we don't really have beforehand. And also if we move to drones, or other modes of transportation, we don't really have empirical measures for how long time it will take or what the distance will be if there are some obstacles on the way. So also very interesting work. Now moving on to Annarita, your inventory routing with multiple depots. So I really enjoyed your presentation, and you showed really big savings of some 33%, which is impressive. As I see, inventory routing is in particular interesting if you combine it with some other routing tasks, because inventory routing gives you some flexibility, and you can use this to serve some critical customers who are willing to pay some extra for having a delivery now, and then you can use your inventory to postpone some of the routings. So this could somehow be an area for future research. Also, I think your ideas could have applications in maritime shipping, where there's a huge potential for inventory routing. And as you said, adding real-time info, both historic data, but also forecasts, could make the problem really challenging. Finally, Lavinia, the raisin in the sausage end, as we say in Danish, or in English, icing on the cake. So your talk was a beautiful example of somehow extending classic network problems with new technologies, and using, for instance, drones and vehicles for inspection tasks. And as you write on your slides, the next step would be really interesting to use data science to handle the stochasticity in these problems. And to somehow wrap it up, your inspection routing, it would be interesting to see if it could be used for inspecting wind farms, like Martina described in the first talk. So using drones and finding routes for inspection. So perhaps you could find some collaboration with Martina. Wrapping up, so when I was a young researcher, I attended a summer school on OR in a EURO summer school on combinatorial optimization in Paris, and the outcome was some thoughts on operations research, where we PhD students wrote this paper together. And an idea to EURO could be to ask some young researchers to share their thoughts on the green transition in energy and transportation. So with these words, I will give the idea on to EURO. So thank you very much.
Thank you very much, David. That was really, really interesting. So first off, just to go back to our wonderful Young Women for OR, we haven't actually given them a little round of applause. So feel free if you want to use your emojis or whatever, just to say, I thought they were fantastic. And I loved the way there was there were common themes throughout all of the talks, and I love the way David has pulled them together. So I think really it gives us great comfort that the future of OR looks really bright. And I love David's idea of that collaboration and pulling all of these themes together. I think it's fantastic. What we're going to do, and I just see we're at about 1:45, which is excellent. So thank you to all our speakers for keeping on time. Thank you for synthesizing your wonderful work into such a sensible, coherent description in only 5 minutes. So that in itself is a feat of achievement. I want to thank everybody for now. We're still going to have lots of work to do. So thank you to David, to all of our speakers on support today. We have Nuncia from the Euro Wisdom Forum and Tricia Walker from the UCD Energy Institute. So we're delighted that we have so many people that we can potentially collaborate with. And thank you also to the Euro Wisdom Forum PR subcommittee for the organization on things. What we're going to do for the next couple of minutes is we're going to have some common discussion here together. So we have 37 people in the webinar with us today, but because it's a webinar, you can all turn on your cameras and you can turn on your mics. We have 2 questions in the chat, or 2 comments in the chat already, and they're really just congratulating you on your wonderful work. What we can do is people can either put comments or queries into the chat, and myself and Nuncia will moderate and read out any questions. So invitation to everybody who's here, if you have any comments or questions you want to pose to our speakers, please feel free to put them into the chat. And because we have a small group, you should be able to unmute yourself and speak. I'm just going to pick out one quick theme to throw it open and get the discussion starting. So I loved that there was that intersection with what's happening in data science. I know Dolores is there as well, and she has some great initiatives going, connecting data science with optimization. Out of all of the talks, I'm just going to pick one question because I have so many. It would be unfair for me to hog the floor. But let me see, who was it? Was Meltem. You said you used a case study where you had 515 and 924 households. I'm just wondering what that data set was, or is that an open data set that others of us could use? And please, while Meltem is answering, the rest of you, if you want to put any comments or queries into the chat, please do. Go ahead, Meltem.
Yeah, thank you. We use 33 bus network, IEEE 33 bus network, and we edit houses, and data we compromise different case studies that we have already data. But we just included houses to the network.
That's an excellent idea. See, Christina is on the chat today, and we also use that IEEE 37 node network and used it as a simulation basis, if you like, almost.
Yeah.
It's Christina, I can see her nodding. Excellent. So any questions anybody wants to pop into the chat, or we have enough of us, I think a few enough of us, that if anybody wants to unmute and just ask a question or add a comment. I'm going to go with one more there while everybody's been very quiet, and I'm trying to remember who showed us those lovely pictures. I think maybe was it Alina, you showed us those lovely GIS images of, it was Vienna, wasn't it? And you had a quarter of a million customers?
Oh, yes, almost, yes.
Almost, well, that's a lot of customers. But I'm just wondering specifically about the geography of Vienna, which, as you showed us, has the river down through. Was the river itself a particular issue when you were doing your data synthesis and modeling?
Not particular. The point is that right now we're just using Euclidean distances basically, and the point is that we want to estimate this. So we are hoping that a machine learning network can actually know that if you pick 2 random nodes basically, that at some point after enough learning, it sees that there is a river, that you always have to go over the bridge to reach the points that are on the other side. And yes, we were thinking it always depends on what information you give to the network, but apart from the coordinates, you also have information about the districts and sub-districts that you have. So maybe those 2 would be enough to say, okay, in this case, you need to have a larger factor to multiply with the Euclidean distance than if there are some 2 neighboring districts that are not split by a river.
Cool. And I love David's idea about what would those models look like if it wasn't just distance we were minimizing, but what if we were minimizing emissions? So those GIS things that can tell us a little bit about the road network and slopes and those kind of things, I think that'll be really, really interesting. I'm going to throw open to the floor again. I'm sure some of you have some comments or questions you'd like to add. Go ahead. Yep. So have we anybody with comments or queries or questions? Or are we ready for our networking and coffee break? We ready to move to networking and coffee break? So I'll just maybe pause one last time. Any of our participants that want to ask any kind of either specific questions or general questions? Or are we happy to go to our networking? Okay, I think at this stage then, if everybody's all quiet, Tricia is helping us here with our organization. What we're going to do is we're going to go to some breakout rooms, and then it's a much smaller group, so you can ask more detailed questions of the speakers if they happen to be in your room. If you don't like your room, you can exit and come back to Tricia and she'll put you in a different room. But before we go there, Nuncia, could you just bring up our slides again, because we're not going to come back all together after we go to our coffee, so we'll be saying goodbye now to the whole group in a minute or two, but I just want to bring a couple of other things to your attention before I let you go. And this is about what Wisdom is doing next over the next while. So the I4s, so I4s is the umbrella network that has EURO as a regional member. They have a global webinar coming up on the 29th of June, and it'll be looking at the gender dimension of OR and what the regional initiatives are. So I'll speak about what we're doing in Wisdom, and we have somebody then from the other regions, Asia, North America and South America. That's coming up, so you can hold that in your diary. And then we've mentioned that EURO is coming up. So the EURO conference virtually in Athens. Many of us are not getting to travel this year, unfortunately, but we're delighted that our young women will be presenting, and they'll have much longer than 5 minutes to talk about their work. So they'll probably have their own presentation in some of the streams, but they'll also within the Wisdom stream be talking in more detail about their work. And we also have a very nice workshop coming up at EURO, where we'll talk about networking as a career progression strategy. And then the young women for OR who haven't yet spoken, we'll have a webinar with them in September, so you can hold that date in your diary. Last things to tell you about is that our white paper, as we said, has been endorsed by the EURO Executive Committee, and it talks about promoting gender equality and inclusivity within EURO. We have some research work that's ongoing. So there were some lovely themes there about connecting up some of the ideas people are working on and collaborating a little bit more. We're looking at collaboration networks within the OR community. So who's collaborating with who, and we're interested in developing that. We will be running a survey in conjunction with the EURO conference, just to get the status of gender within OR. We don't actually know how many men and women we have. We don't know what the breakdown is. So it'll be interesting to find out some of that. And we are also designing some interviews to get a more in-depth understanding of people's career paths within OR. So more information on that on the EURO website. You can see down at the bottom there at the EURO website link. You can email us, you can join us on LinkedIn. If you're interested, you can become an ordinary member of Wisdom. And all that means is that you support us in our ambitions to achieve our objectives. So I'm going to thank again Nuncia particularly and Tricia for helping us today. Just come back to the chat and see, have we any last questions? I don't think we have any questions. So again, thank you very much to our wonderful speakers today. Tricia, if you can, will you put us out to our breakout groups? And thank you, everybody. Looking forward to seeing all of you again at some future events. And I'll come into a room now and talk to some of you. Thank you, everybody. If you want to turn on your cameras, we'll try and get it.